Hi, Dr. Huan here. In this lesson, we'll look at integration of the log functions. So first of all, here's the rule. The integral of 1 over x is ln absolute value of x, not just ln x. We have to add the absolute value sign. The integral of 1 over u will be ln absolute value of u and then plus the constant c. So now let's do some problems. Okay, let's look at the first one. So we can directly apply the rule, right? The rule number 1. So this is equal to, move out the 2, and then the antiderivative of 1 over x is just the ln absolute value of x plus c. We can actually write this in a little more compact. So, which means let's bring the square as an exponent, and because of the square, this guarantees to be non-negative, right? It's always positive. X cannot be 0. So therefore, the absolute value sign is a little redundant here. So we can just write it as ln x squared plus c. So this answer, compared with that answer, there's less complicated looking because there's no absolute value sign anymore. Now, what about this one? What about this one? So similarly, this is just move out the 3 and find the antiderivative of 1 over x, which is ln absolute value of x plus c. Now, if you want to rewrite that the 3 as exponents, you can. And the equivalent. Question for you. Are you able to remove the absolute value sign? Actually, you cannot, because if you remove absolute value sign, x cubed can be negative or positive. So it won't be guaranteed as positive, right? So you cannot do that. So again, you cannot just say that, okay? Here, this x has to be positive, and here this x, as long as it's not 0, it's okay. So therefore, these two are not equivalent, but these two are equivalent. So you can either write that or that. Absolute value sign cannot be skipped. Now let's take a look at this one. Pause the video if you would like to give a try first. And this one involves the substitution. Let me zoom in a little bit here. So here we're going to call the denominator as the u. So u is 5 minus 4x. And your du is negative 4x. Negative 4dx actually. Which means dx is negative 1 over 4 du, right? Now let's do the substitution. So here this dx is negative 1/4 du. I can pull the negative 1/4 outside of the integral symbol. And here we still have 1 over the u. Okay, and then we can apply the rule directly. That's the ln absolute value of u plus c. And now you can do the backwards substitution, plug in the u, which is 5 minus 4x. Okay. Now let's take a look at this one. Let me move to here. So I hope that with enough exercises, you are able to recognize this form as that's applicable to the log rule. So call this as u. You can see this is part of your du, right? So therefore, it will be 1 over the u form, this quotient form. So let's do that. Let u be 2x cubed plus 1. And the du will be 6x squared dx. And the good sign is you see the x squared dx, which is this part. So let's solve for that. This means x squared dx is equal to 1 over 6 du. Now let's do the substitution. So x squared dx becomes 1 over 6 du, and then I'll pull the 1 over 6 out of the integral symbol. And now I have 1 over, this is in the denominator, right? So it's going to be 1 over, this is my u. This is u. And then this is equal to 1 over 6 ln. Well, it's very easy to forget the absolute value sign. So this is pretty common mistake from students. So don't forget about the absolute value sign. This is going to be your u, right? So let's just plug in the u immediately, which is 2x cubed plus 1. Now let's ask, is this absolute value sign necessary? I think so in this case, because x cubed being the odd power, this guy can be negative or positive. So with the absolute value sign, that guarantees this is non-negative. So therefore, we do need the absolute value sign here. Now let's move on to the next problem. This time, let's take a look at one application. So in this case, you are given a function. This function is x squared plus 4 divided by x. We want to find the area of the region bounded by this function from 1 to 4. So the area is equal to, from 1 to 4, we integrate x squared plus 4 over x. When you have one single term in the denominator, best way is to split them. So we are going to split that into two terms, x squared over x, which is x. 4 over x is the second term. And then we are going to integrate term by term. Antiderivative of x is x squared over 2. And the antiderivative of 4 over x is the ln absolute value of x. And then don't forget that the limit goes from 1 to 4. Now let's plug in 4. When x is 4, you have 4 squared, which is 16 over 2, plus ln 4. And minus, when x is 1, this is 1/2, plus ln 1. Absolute value sign is not necessary because these numbers are positive. And ln 1 is just 0, right? So therefore, our answer becomes 16 over 2 minus 1 over 2, which is 15 over 2. 15 over 2 plus ln 4. So this is the exact answer. Numerically, this is roughly around 13.19-ish. All right, so now let's take a look at the next example. When we have a fraction, rational function like that, especially the numerator degree is larger than the denominator, we do a long division, right, before we do the integration. So let's, on the side, let's do the long division, x plus 1. We need x so that we get the x squared to eliminate the leading term. So therefore, I'm going to write the x above this x term. So we have x squared minus a plus x. And we'll do a subtraction. X squared minus x squared will be gone. That's how we find the x. Negative 3x minus x. That will be negative 4x. Don't add. You have to subtract. Now move down the next term. And we need a negative 4 here. And negative 4 times x is negative 4x. and negative 4 times 1 is negative 4. And again, we have to subtract 2 minus the negative 4, which is 2 plus 4. So we end up with 6. This means this quotient actually is x minus 4 plus 6 over x plus 1. And then we integrate term by term. Antiderivative of x is x squared over 2. And the next term is minus 4x. And this is where the natural log of x comes in. So plus 6 times natural log of absolute value of x plus 1. And then plus c. Alright, let's move on and then look at a few problems. Sometimes they may not be that obvious, right? So the more exercise you do, the more life experience you have, and the better you are in solving problems like these. Now, oftentimes when you have a polynomial in the denominator, if it's possible, try to make it one term so that you can split the terms. So here, let's call x minus 5 as u. So let u be x minus 5. And then oftentimes you have x and you really have to do the substitution. So how about we quickly solve for x here? X equals u plus 5. Now du is actually equal to dx, and we can now do the substitution. 6 times x is u plus 5, divided by the bottom is just u squared, right? And dx is actually the du. And now we can split that into two terms. This is why having a single term in the denominator is nice. You can split them. So the first term will be 6 times 1 over u, basically 6 over u. The second term will be 6 times 5, which is 30. So 30 over u squared, 30 over u squared, du. The antiderivative of 6 over u, that's the natural log of absolute value of u. So I'm going to keep the u for now, but if you feel comfortable, you can quickly plug in the u now, just in this step. The second one is the 30 over u squared. So please note that if you are doing this, that will be incorrect, okay? We do the natural log when you have these exponents 1 and in the denominator. When this is not 1, you can actually use the power rule. So think of this as u to the negative 2. So when you integrate the u 1 over u squared, think of it as u to the negative 2. So now plus 30 times, according to the power rule, negative 2 plus 1 on the bottom, u to the negative 2 plus 1 in the numerator, plus c. So now, finally, this is equal to 6 times natural log of the u is x minus 5, absolute value sign with. And here this is negative 1, so that will become negative 30. And this is u to the negative 1, which means 1 over u. So therefore, this is going to be negative 30 over the u, where u is x minus 5. So therefore, this is the answer for the first one. Now, let's look at the second one. Second one, you already see how nice it is when the denominator is a single term. So let's make that happen, okay? So let u be square root of x minus 3. Just give a try to see what you get. Now we will have to do the substitution for the numerator, which means square root of x is going to be u plus 3. And let's figure out the dx. Okay, so du is equal to the derivative of square root of x. We will use power rule, x to the 1/2, right? So think of this as x to the 1/2. It will be 1/2 times x to the negative 1/2, which means 1/2 square root of x dx. This means dx is equal to 2 times square root of x du. And the square root of x, I'm going to do the substitution right there. So this is 2 times u plus 3 dx, du. So it seems like everything's ready. Let's do the substitution. Square root of x is u plus 3. And dx is 2 times u plus 3 du. And the bottom is just your u, right? So basically we have, let's pull out the 2. The top, you have u plus 3 times u plus 3, which becomes u plus 3 square. Let's expand it. So u square plus 6u plus 9. I'm using the perfect square binomial formula there. And the bottom is just u, okay, du, which gives, once we have the single term in the denominator, we can split them. So we have split that into the following terms. The first one is u. The second one is just 6. Next is 9 over u du. Let's move up a little. So now finally, the antiderivative of u is u squared over 2, right? U squared over 2 multiplied by 2. So therefore we just have u squared. So u squared plus antiderivative of this is u, 6u, well, multiplied by 2, which is 12u. That's where the natural log, so 9 over u will be 9 times natural log of absolute value of u, but multiplied by 2. So therefore we have 18 ln absolute value of u plus c. Now we are going to do the substitution. U is square root of 3 minus square root of x minus 3. Oh, by the way, this is square. Plus 18 times ln square root of x minus 3 plus c. We actually, in this case, we can simplify this a bit. Okay, let's expand it. Using the perfect square binomial, we have square of the first one, which is x, minus twice of the product of these two terms, which is 6 times square root of x plus 9. And the next will be 12 square root of x minus 36. And copy down the very last term. And we can see that these two are like terms, and which gives us positive 6 square root of x. Now, because I do have a arbitrary constant, I really don't need to keep these, which is negative 27, right? I should combine that into my arbitrary constants, so I'm not going to write it. So but I still have a 18 natural log absolute value of x minus square root of x minus 3 term. So plus, this will be a new c. So this c will be the combination of this previous c with this negative 27. So let's actually call this as C and call the previous one as C1 to distinguish those. So where this C is equal to C1 minus 27. It's a combine of the C1 and these numbers. Okay, so now this is the answer. All right, let's do another example here. Continue to do another example here. Now, let's look at this new one. Here we have a ln(x) in the bottom and an x also another term together with ln(x). So do a little observation and pause the video to see what would you like to call u. So here actually you don't want to call the whole thing as u, you want to call u as ln(x), because the du, which is 1 over x, you see the du right there, right? So that's how you should approach this problem. So du is 1 over x dx. And now this 1 over x dx, that's your du. And the ln(x) in the denominator, that's your u. So this is just using the formula ln absolute value of u plus c, where the u is actually ln(x). So therefore, this is the answer for this one. It looks a little strange, but actually it's quite simple here. Time for us to look at some, to derive some trigonometric formulas. So here are the 4 formulas that sometimes you will find it useful. And let's derive these 2. The other 2 are derived in a very, very much similar way. Now let's look at the tangent x. Oftentimes a hint is oftentimes rewriting a function using the sine and cosine will be helpful. Tangent is sine over cosine. And then we cannot do the direct integration, so let's try to think about substitution. So if I call the bottom cosine as the u, I see the du there, right? So let's let u be the cosine. Then du will be negative sine x dx. So therefore, sine x dx will be equal to negative du. So negative du over the u in the denominator. And this is equal to negative ln absolute value of u. And what is my u? It is cosine x. So this is one answer. Now, we can actually, this negative 1, move this as an exponent of cosine x, right? So we can actually do that. ln cosine x, well, raised to power the negative 1, okay? Exponent is negative 1. And the this is 1 over cosine x, which is secant x. So ln absolute value of secant x plus c. Therefore, we actually have 2 versions for this one. So tangent, the antiderivative of tangent u is ln absolute value of cosine u plus c, or ln secant u plus c. Now the cotangent u, it can be derived very, very much similar, which is this guy, ln sine u. Let's take a look at ln the antiderivative of secant. Believe it or not, actually there are many different ways to derive this formula, the formula for this one. One of the smart way is to use the substitution, okay? And then, but in order for you to use the substitution, first multiply the top and bottom by secant x, plus tangent x over secant x plus tangent x, basically multiplied by 1. And you will see that when you multiply the numerators, you have secant x squared plus secant x tangent x. And at the bottom, you have secant x plus tangent x. Now you can see that derivative of secant is actually this guy, right? And derivative of tangent is actually this guy. So therefore, when you let u be secant x plus tangent x, the du is exactly what you see in the numerator. Secant x tangent x dx. Okay, so therefore it becomes du over u, and this gives you ln, absolute value of secant x plus tangent x plus c, which is this formula. And I strongly encourage you to give a try to see if you are able to derive the formula for the cosecant u. It will be very much alike again. Now let's move on to the next problem. So let's do some basic integration that involves the trigonometric function, the tangent and cotangent basically. So again, these are the formulas available. The first one, first of all let u be x over 3. Du is gonna be 1/3 dx, or 3 du equals dx. Do the substitution. We have cotangent x over 3, that's the cotangent u. Dx is 3 du, right? And therefore we have 3 times ln, using the formula above, ln sine of the u, so u is x over 3. Let's do the backward substitution immediately, plus the c. Let's try one problem that is the definite integral. So here we have 2 theta inside, so let's do the call the u as 2 theta, which means du is equal to 2 d theta, or 1/2 du is the d theta. So that's, we solve for d theta. And this is a definite integral, so let's change the limits at the same time. So when x is equal to pi over 8, the lower limit, your u, which is 2 times theta, which is pi over 4. When x is pi over 4, your u is double it, which is pi over 2. So now this becomes pi over 4 as the lower limit, pi over 2 upper limit, cosecant 2, well, not 2 theta anymore, it's cosecant u minus cotangent u, and times 1/2 du, right? So I'm gonna pull the 1/2 out and du. Antiderivative of cosecant u, if you still don't remember, so it is this guy, which is equal to negative ln absolute value of cosecant u plus cotangent u. And then the second one, the antiderivative of the cotangent u is ln sine u, but there's a negative sign there, so it's minus ln absolute value of sine u. Okay, and let's write the limit. The lower limit is pi over 4, The upper limit is pi over 2. Let's evaluate it now. So let's first plug in the pi over 2. So cosecant pi over 2 plus cotangent pi over 2 minus ln absolute value of sine of pi over 2. Actually, this is we plug in pi over 2 here into here, right? Now, time for us to plug in pi over 4, so minus the pi over 4 ln cosecant pi over 4. I'm sorry that I wrote it wrong. This is when I say cosecant, right? Cosecant. So let me. So this actually is going to be cosecant pi over 2 earlier. Now this is cosecant pi over 4. Cosecant pi over 4 plus cotangent pi over 4 minus ln sine the pi over 4. Now this is equal to 1/2. Okay, now let's try to remember this is 1 over sine, right? So therefore sine pi over 2 is 1. So basically this is 1. This is 1. Cotangent pi over 2, this is 0. And sine pi over 2, this is 1. Cosecant pi over 4, this is square root of 2 because cosine sine of pi over 4 is square root of 2 over 2. The reciprocal will be square root of 2. And this is 1. So now I think we are ready to evaluate. Oh, just one more. This is equal to square root of 2 over 2. This is ln 1. Basically, this is 0. And this is ln 1. This is 0. So this whole term becomes 0. And this is negative. Well, when we drop the parentheses, this becomes positive, and this becomes positive. So therefore, we have positive ln square root of 2 plus 1 plus ln square root of 2 over 2. Now we actually can, because this is plus sign, we can condense it into multiplication. So this is ln of square root of 2 plus 1 times square root of 2 over 2. And finally, we multiply this in. Square root of 2 over 2 times square root of 2, which is just 1. And then plus square root of 2 over 2. Here, quite a bit of algebra, right? All right. Lastly, let's do another application here. Find the average value of this function. And the average value function, the formula is 1 over b minus a. This is your a, this is b. So e minus 1. And integrate, you have to integrate from 1 to e. And this is 2 ln x over x dx. Again, pause the video if you want to. We are going to use the substitution. Call this as your u. So let u be ln x. Then the du will be 1 over x dx. And let's change the limits as well. When x is equal to 1, your u is equal to ln 1 is 0. When x is e, the u is ln e, which is 1. So now this is equal to 1 over e minus 1. The limits becomes to 0 to 1. This is 2 u du, right? This is the du, this is the u. And the antiderivative is just u squared. And plug in these two limits. which becomes 1 over e minus 1. When this is 1, it's 1. When this is 0, it's 0. So it's 1 over e minus 1.